Welcome to the webinar. My name is Amanda Burma. I'm with FrogLogic, and today we'll be going over code coverage and analysis using FrogLogic's Squish Coco. For those of you not familiar with FrogLogic, we are headquartered in Hamburg, Germany, and are privately held. We were established in 2003 and have customers all around the world and have been profitable and with steady revenue growth since 2003. Now today we'll be talking about Squish Coco. Squish Coco is our code coverage toolchain. It's cross-platform and works with C, C++, C#, and Tcl applications. It's made up of a coverage scanner, what's monitoring any actions you're performing within your application, so monitoring the code that you're exercising, a coverage browser that allows you to view the analysis and the information about the code that you've exercised, as well as a Visual Studio add-in if anyone's working with Visual Studio. It's also supported across a number of different platforms. It's supported on embedded operating systems with a very minimal footprint on those operating systems because we know space is at a premium. And then it's also supported across Linux, Mac, Unix, and Windows. Now, Squish Coco, like some other code coverage tool chains out there, is going to help you identify the code that you're exercising. But with Coco, there's some things beyond what some of the other tools out there identify. You have the code that you're exercising, identifying dead code or code that's not being tested, helping to find redundant tests. And then we've also introduced what's called patch analysis. So analyzing the impact of a patch on the code, what tests cover that impacted area, or if no tests cover that impacted area. So that, as well as some other reporting and analysis, are going to be demonstrated today, showing you how no matter the type of testing that you're doing, GUI, manual, regression testing, unit testing, etc., this toolchain, this code coverage toolchain can be really helpful at any level of testing. Now, when working with Squish Coco, as far as compilers go, it works with GCC and your other platform standard compilers. And then there's a number of different code level options. So, you know, when you look at some coverage tools out there, they may offer line coverage, for example. Well, Squish Coco goes beyond that. We're offering function coverage, line coverage, branch coverage, branch with line coverage, and then one of the ones I like to also demonstrate is the branch decision and condition coverage, showing you the difference in coverage information that it provides. You'll also see today how you can help focus your testing efforts by either determining an optimal test execution order for a set of tests in a given time frame, seeing how much those tests will cover in a given period of time and what order might be best to cover the code. You also have the ability to identify what code is impacted by a patch and the tests that cover that set of code, and then compare your testing coverage between application versions as well. So with that, we'll switch over to the demonstration. So what I'm going to do today is work through just a sample application that we have some unit tests for and show you how it works with this sample application. Now, what I'm doing today is also available in our tutorial, so when you evaluate Squish Coco, you can follow along with something very similar in our tutorial. So the first thing that I'm going to do is just open up our command line interface, but I want to have some settings set when I open that command line interface. So you can see here, I'm simply saying, you know, what my Squish Coco path is, plus that I want to use my coverage scanner's specific environment. So if you were to go into your Squish Coco path, you'll have a batch file with your coverage scanner environment in there. So I'm going to open that up, and that's also putting me in the proper path for this particular C++ application that we're going to work with today. So what I'm going to do first is I want to compile this file using my make file. I can do this just to make sure it compiles, But then I can also do this and I have some unit tests associated with it. So if I provide the test parameter, it will also run my unit tests. And before we even start incorporating Squish Coco into this, we want to make sure that this part works. That's going to execute the unit tests associated with this particular application. So you can see now that all the unit tests ran successfully. So what we're going to do now is we're going to begin incorporating Squish Coco into this. How can we instrument our application so that Squish Coco can monitor the code that we're exercising? And it's important to understand that you don't have to make any code changes to your application in order to do this. So the first thing that we want to do, we already compiled the application, right? We have the applications compiled within here. And so to make sure that this environment is clean, because we just ran some of those unit tests, let's do a clean compile here. Now what that would also do is if we had instrumented this particular set of code with Coco before, and the reason it's saying that it can't find certain items here is because it's looking for items that are specific to Squish Coco as well to remove. But we don't need to remove those, they didn't exist yet. And so now what we're going to do is run this instrumented.bat file. But if we come and look at that file, just so that you can see that first, you can see that, again, we're looking at our Squish Coco path. This happens to be a Visual Studio C++ application. And then we're also turning this coverage scanner flag to on. Now, the other thing you'll notice over here is not only can you turn the coverage scanner flag on, but you can also exclude certain paths, or you can exclude files based on wildcards, etc. We're going to do that later. This first one is just going to compile and instrument the application with just this CS on flag. So let's do that here. Now, in me calling the test parameter, it's not only instrumenting the application with Squish Coco, but it's also executing those unit tests. And you'll notice above here, it's starting to generate a lot of these CSMES files. Those are the measurement files for the various code that's being exercised. Now, the name of our application is called parser. So if we look down here, we can see there's the parser.cpp file, and it's still compiling everything. All right. So what we have now are unit tests completed. We've instrumented the application using Squish Coco. And what we want to do now is take a look at these measurement files. So the -m in this next call is for the measurement files, the E's for the execution file. So we're actually going to take a look at the unit tests executable and not the parser executable to take a look at the results for the unit tests that we executed for this particular application. All right. Now what that does is that's opening up our coverage browser. So this is our coverage browser, but with the load execution result dialog open. What I can do now is I can give this particular item a name. If you take a look here, it's importing the file that we said. So that's for that executable. And then we can indicate whether it passed or failed, but that's something that we're actually passing in from our measurement file. So we don't need to do that right now. So I'll click import. And we have our status set to unknown here in our summary. But when we come over and we take a look, you can see here executions, and actually we still have the state set to unknown, so we didn't pass the state of that test, whether it passed or failed, to that measurement file. That is an option that you do have available. So all those unit tests that just ran are part of one execution. If we take a look within the coverage browser, you have your execution. So we had one execution. We'll go over an example later that has multiple executions. And when you have that execution selected, you can then also select the coverage method that you're interested in viewing for that particular execution. That will then show you any statistics about the execution as well as explanations. So let's take a look at that now. You'll notice, because we didn't filter out any of those files that maybe weren't as important to us, that this is quite extensive. It even includes my unit test files. So we're going to take a look at parser.cpp, and we can come take a look at the coverage for this, for example, for this particular area. Now, the coverage is going to vary, and the analysis is going to vary based on the coverage method that you select. Currently, I have branch, decision, and condition coverage selected. Before we get there, let's just go to line coverage, for example. Given line coverage here, we can see, looking at the same area that we were looking at with the other coverage, we can see our percentage of coverage, we can see what lines passed, were executed rather, what lines weren't executed, and then as we hover over those different lines, we can see additional information or an explanation about that. The explanation down below. I'll show you later when we generate an HTML report. This information that we're reviewing now is also available from your reports, so available to individuals outside the coverage browser who may not have access to the coverage browser. So it's telling us that with line coverage for this particular execution, which was a number of different unit tests, that we have 35% coverage given line coverage. Again, the instrumentation will switch to branch, decision, and condition. That one's revealing a 30% coverage. And if you take a look here, the difference between that line coverage or some other coverages and this particular coverage, you can see, yes, while this if statement did execute, it executed actually 9 times across the different unit tests. It only executed to false. Not once did it execute to true. So we haven't fully covered that particular area. So that's where the various types of coverage methods can really reveal other information. Now I can also take a look at other source files, various functions, and we'll also look at different executions. And then you have your undo and redo. As I work through and look at different ways of analyzing and seeing the information, I can always click back and see how I was looking at that. The other thing that I can do is I can come up to my reports, and in my reports I can generate a number of different types of reports. So let's say that we're looking at the condition, decision, and condition, branch, condition, decision, and condition coverage, and then I'm going to export a HTML report. When I do that, I'll have the location of my report, so my path here, what I'd like to include in my report, the maximum number of executions to include in that report, etc. So from the report, you'll notice you have a lot of information very similar to what you had in the coverage browser. You have your executions. Again, we're only dealing with one execution so far. You have your various source, so the different source files, whether I'm sorting it by source or by percentage coverage. And then I can go and I can look at my different source files and see information about that source file. Now, this is similar to what you were seeing in the coverage browser, right? As I hover over these different items. Now, I've exported this report to have the branch, decision, and condition coverage. Whatever you would like to export the coverage method as, it will then appear here within the report. So that information is available, as well as, your functions, directories, executed code, dead code, etc. You can dive into it. You can see that code. You can see where that information is identified. All directly from within your HTML reports. Now that was for a single execution. Let's take a look at how else we can use this. So instead of having the single execution there, we're going to take a look at our patch analysis feature. So instead of looking at this version 1, I'm going to come into version 2 of my parser file here. And you'll notice I've run this before. So we are going to want to clean this up a little bit. So I'm going to run a make clean. But before I do that, I do want to show you, okay, that's the same thing. I'll show you the instrumentation file before we get there. So we're going to back up in our slide deck here a little bit and run. Now, as I do that, you'll notice a number of these different files disappeared, but the main 2 database files for the coverage didn't. Those are from an example earlier today, so I'm going to delete those so that they're not part of our example that we go through. All right. So the other thing I'm going to do is call this instrumented.bat. If you remember before, all it did is turn the coverage scanner on, but now what we're also including is a parameter to exclude a path. So we're excluding the path that has our unit tests in there, and we're excluding all the unit tests CPP files from and the unit test listener from our coverage, because we don't want to include that in our coverage. Those are part of our unit test, not the actual application. So we'll call that from here. Again, we're calling the test so that it executes those tests as well, the unit tests. So it's executing the unit tests, and from there, you'll notice behind here that it is also generating the different measurement files, but only for those which we indicated we wanted to indeed measure. So not for all the unit tests. Okay, so it looks like everything ran okay here, and it's complete. So now what we can do, just like we did before, now we're going to import this to the coverage browser, our results. All right, so it's doing the same thing, allowing us to load that execution report. We can do so manually if we'd like to, from File, Load Execution Report. And here this time, instead of having the individual execution, what we have here is all of our different unit tests are showing as different executions and importing over here in our executions as different executions. So what we can do with that is we can see all of the executions together, or we can take a look at individual executions and see the coverage for those individual executions. You'll also notice, because we indicated to not include certain source files and functions, that this list is much more applicable to what we're looking at, doesn't include our unit tests, etc. So if we come down here, we can see for this particular test plus what this particular unit test is covering, what it's not covering, the line coverage, as well as the branch decision and condition. We can also enable it for all of them and see how it covers the various functions, and you can go into those as well and see their coverage. Now with this, one of the things that we're interested in is what is the optimal execution order? What order would it be best to execute these tests in given time restraints, let's say? So if we go to reports, or actually we're going to go to tools, optimize execution order, it will then tell us the order in which we have the most coverage and then the least amount of coverage added. You can export this to an HTML report as well. Now let's say that we have this version 2 that we're working on and we make some changes. We want to apply a patch. But when we apply that patch, we want to know the risk associated with that patch. And so that's where we get to our patch analysis. So what we're going to do is you're going to run a diff across two different versions of your application. So that's independent of the coverage browser. You run that diff. Now once you have that diff file, then you can see the differences between the two as analyzed by Squish Coco. So again, you have your diff file. Your diff, if we just open it up in Notepad, for example, is going to show us the differences between what was added, what was removed, just as it would in any diff utility. But we're going to take a look at it from the patch analysis standpoint. So to do that, what we're going to do is we're going to take these executions from our prior version, so version 2, and look at the diff between version 2 and version 3. So if I click Reports and click Patch Analysis, I can then indicate where my diff file is, and then where I'd like my report to appear, the maximum number of executions, and other information I'd like to include. So what that does is that generates this file. And from here, we can see what's passed or failed as far as the test executions go. We can see the number of lines that were removed, inserted, the total modifications. We can also see the tests that were influenced by this change. So your potential for regressions. All of these passed, so that's a good thing. And then we can see the file that was modified or files that were modified. And within the modified files, we can see here, for example, that one new line was added, 2 were removed, and 0 tests apply to this area. So you want to take a look at how many tests apply to the area impacted. Does that mean that perhaps that area needs more testing? Or here you can see that while this area changed, the unit tests still passed for that area, and there were 4 different tests which executed across this area. So we have an area that wasn't covered previously, still isn't covered, but contained a change, an area to potentially test. So it's kind of some risk analysis for your patch. And then down here, there were 2 lines removed, a line added with 8 tests that applied to this execution. And here, 2 lines removed, 1 added, and one of them had a line that used a test, and now there's 3 different ones that do. For the current one. So you can really begin to see and understand not only where your changes occurred, you can see the new line numbers versus old line numbers, what was removed, what was added, as well as the impacted tests or areas where there are no tests that work with the items that were changed. So some untested areas in an area where there was a code change. So that patch analysis feature is newer, and is something that we haven't seen in other applications out there, and we really believe provides a lot of insight into the code coverage and information. Here's some more information about the patch analysis, some things that we went over in our example, and things that the patch analysis helps you think about. So with that, I'd like to thank you for attending our webinar today. I do encourage you to go out and evaluate Squish Coco by going to froglogic.com evaluate, during which time you'll have access to our support. You can email squish@froglogic.com with any questions. And we also have our documentation at doc.froglogic.com and our knowledge base at kb.froglogic.com.